in this demo, just conscious of time here, what we're going to show is, okay, in contrast to that when do I failover and what's going on, we're going to show connected to the system on-prem in the data center, like the client we kind of shown that in that graph. And then we're going to go, okay, hey, you know what? We're worried about the hurricane coming in. No problem, no stress. I'm going to go ahead and stop using cluster on-prem, and I'm going to send my government employees for the municipality. We're doing the crime center for looting or looking at video surveillance. I'm going to send them to a safer location. I'm going to just hand them a little Asus Nook like this. They're going to go home. I'm going to scale out the performance of the system on-prem or in the cloud, because now it's the only thing handling all that I/O. I don't have that nice hot cache system on-prem. And then we're going to deploy, we'll show how the connection works for the employee then to the Nook to get that same data, and then return it all back to the office afterwards, assuming everything was there and nothing got destroyed. But even if it wasn't, they could still maintain continuity. And along the whole way, if they wanted to be able to do, PC over IP to virtual desktops in the cloud as well, they could. This is just an alternative way to do it. There's pros and cons to each approach. The nice thing is when you say that you're very flexible and elastic and you can do a lot of different things, you end up with a lot of different variations of what people want to do, and we had to kind of narrow down what we would show. So anyways, my driver today is Mr. Mike Schmiel, newborn father. Just want to give congrats to him there. To be honest, you didn't really do the hard work there, but congrats anyways. And he's going to help drive while I do my best to narrate on this journey through the impending disaster. So here I am. I'm in the local office connected to my normal SMB share. No big deal there. I have local data that could be from the Crime Watch Center or evidence or GIS images, whatever flavor of employee you want. And you know what? Now I want to connect this on-prem cluster into the cloud cluster so that I get to see all that data. So imagine this is maybe a new build out of another government building, or they changed offices, whatever the case may be. So I'm going to go ahead and establish a data portal. Now today we do this very easily through the CLI. Soon this will be completely through the UI and Nexus to be able to just easily connect systems together by directory. I go establish and request the portal. I go on the cloud side and have to authorize it. Now the nice thing about this is this allows us to not just do within a single customer this type of relationship, but actually extend to third parties. So you can imagine a situation where I have my data and my hub, but I want to be able to allow access, maybe read-only access or even read-write access to a third-party entity with the ability to revoke that access at any time and have no ability to get to that data with full audit along the way, and be able to extend those portals to other entities. So this could be collaborators for a special effects shop. This could be the FBI coming in, or this could be FEMA, or the Red Cross. They want to be able to get access to the camera data or the GIS data, the blueprints of buildings, and be able to help find people if anything's happened. I can easily give them access in a very secure way that delivers a very high performance local-like system. So faster than I could talk, which is pretty fast, Mike has established a data portal, and boom, now all of a sudden a folder has showed up as if it was local the whole time. It's actually sitting in AWS. And I browse into that. I could see old project data, new project data. So just for the sake of kind of showing you in real time, we're going to go ahead and drag an image into this and write that. Now, this is just simply showing this is a full read-writable spoke. The on-prem system is just a spoke to that hub in the cloud. And, to show that we also didn't, prep everything ahead of time and cache things, this is what you guys today with Doug.
Can you tell me to suck my gut in next time?
Looking great. That was your good side when you turned this way, okay? I think you were throwing things at me at that point in typical employee, boss behavior here. So we've made edits on this, and it's great. The sarcasm of engineering comes out strong. Okay, we're going to go ahead and close this, and that will go ahead and save to the through this data portal. Now it's sitting in AWS, and now what's going to happen is we go, okay, hey, let's go ahead and go back in, and the hurricane's coming. Let's go ahead and shut down that data portal. just for the sake of making sure we flush every single bit of data that's there locally, we're going to go ahead and disconnect that data portal. Now, you don't really have to. In fact, in real time, it's continuously streaming data block by block as it writes to the system, and it flushes very fast. Like I said, the key here is not only doing it at a block level, like streaming data versus file copying data, but also it's getting extremely high bandwidth utilization by using kind of a WAN optimized congestion control in the network. We're getting upper 90s in bandwidth utilization versus single digit on a normal SMB share to the cloud. I used to have customers at AWS be like, oh, I want to go move this workload to the cloud. Great, what is it? It's just a SMB share for all my users, like home directories and file shares. I'm like, okay, so all you're just doing is moving the data away from the users and then connecting it over SMB. That was never meant to do that. That's going to be a very bad experience. I wish I had this when I was there at AWS, but now I'm here, I can take advantage of it. And now help all my friends back there at AWS, give it to all the rest of their customers. So now, as you can see, I've disconnected the data portal. That directory is now gone. So we saw it appear, now we've seen it disappear as we establish the data portal and remove the data portal. Question?
Yeah, so if the system goes down while you're trying to deactivate a data portal, the data is lost.
Any data that was not yet written to the cloud
Is lost.
is still on the on-prem system, but distributed, on a highly available system, as you would with any scale-out NAS. Now, if that connection to the internet was severed before you were ever able to finally flush that data and the data center was taken out, could you potentially lose data? Yes, but here's the key. The key is because it's so easy to do this failover, if you will, which is not really a failover because the data was in the cloud the whole time. I don't have to wait until the last minute. I can do this days ahead of the hurricane and not worry about if and when and how last minute I go with it. Can I get the, if I'm doing the normal approach, right? It's, can I get my snap diff iterative backup to the other other data center in time before the hurricane hits? So it could be the same thing in that situation as well. You'd have data loss for that backup as well. Okay, so now.
So what's the typical write back time? I mean,
as fast as the bandwidth will allocate.
It's basically what the bandwidth can support.
Mm-hmm. Yeah, because of that, of how we've optimized that protocol under that our own protocol of data movement at the 4K block level with WAN optimization, congestion control, et cetera. Instead of getting your typical 2 to 8% bandwidth utilization on like an SMB connection over the WAN, we're seeing high 90s, 95 to 98%. So that really what it comes down to is how much time do I have? What's my change rate? And then you just buy your direct connects available or your bandwidth available to accommodate that. But again, in most circumstances, it actually doesn't matter much because you're talking about a situation where people are, creating data during the day, then they go home. It's still, if the pipe was really small, it's a really remote office, it would still be pushing that data at night when they're not there in the background. Then come the next day, no problem, keep going on. We have actually banking customers that want this simply for video surveillance data or data creating at the branch where, if something happens to that branch, can it still hold that data in consistency? And then, because they were missing their backup windows between branch offices. And so can I have something be moving data 24/7 without having to take the system down for a backup window?
And it's incremental, right?
Mm-hmm. Yeah. It's only change block differentials at the 4K block level.
Yeah.
Yeah.
So very efficient.
Simple math, a 100 gig circuit is about a petabyte a day.
Mm.
So if your change rate, not your total data rate, your change rate is more than a petabyte a day. Oh,
Yeah.
he said over here, I was okay. Then you're.
Yeah, I can imagine for the most of the use cases, not 99.999% is fine.
Yeah, yeah.
The corner cases, what would be the corner cases? Like, let's be honest, what doesn't work? What are those corner cases?
So, there's a lot that does, but to the point of just, what doesn't so far. What I've seen so far is really, really, really high, physical security video surveillance for an entire airport or stadium where they just didn't have the bandwidth to be able to get 20,000 4K cameras to push live feed into the cloud.
So it's thousands of files which are being constantly updated. Okay.
Yeah.
Okay.
By the way, that's also a fairly poor use case because, it's a retention of like 30, 60, or 90 days. So you're just constantly deleting and writing.
Yeah.
And you don't want to pay APIs to delete and write.
Yeah.
So,
yeah.
so that's not a good use case. let's
I
see
had one
what else.
customer I was talking to ingesting 6 petabytes a day. That's 6 petabytes of satellite imagery.
Yeah.
And the problem isn't that it's a problem. It simply just needs more bandwidth thrown at the problem.
Right. Yeah.
Right. So they can ingest that into the cloud. Right. That would be 600 gigabits per second sustained write. And since we can do 8 terabits per second sustained, there's more than enough capacity. They just simply have to provision to it.
Yeah, it's really interesting. This reminds me a lot of the early days in discussions around Hadoop. And kind of like, hey, because Ethernet isn't fast enough, we need data locality to the compute in the distributed Hadoop cluster. And then as networking got better, you could have disaggregated compute clusters for data lakes, which became the standard for everything in the cloud. Every single cloud Hadoop data lake is distributed compute from storage with a high performance network in the middle. None of it's direct attached. And we're seeing the same thing, especially post-COVID. The world is forever, distributed in workloads and compute availability. I mean, you talk about AI workloads, like you want to be able to get your data to any compute available in any region of any cloud as it becomes available instead of just being confined to one. Really we're already, I would say, at the point for the vast majority of workloads where the networks and bandwidth are fast enough with the optimizations we've done and how we move the data. That's one big thing is, typical NAS was made to work in a local area network. It was never meant to do this. So we had to figure out how do I maintain application compatibility on standard protocols, but build a data network that is really meant for the modern era and blend those two things together so you don't have to re-platform applications to be able to still take advantage of this. And networks have really caught up quite a lot, which is good, and it helps us really do cool things like this. So what Mike is showing now is actually running entirely off of this little Nook. So that's the full scale-out multi-protocol, extremely robust file system running on just this little itty-bitty device. It's pretty crazy. I did ask to make it more impressive if I could run it off my phone. And the memory and compute worked, but we don't yet support ARM. So I couldn't yet do that. So we had to run it on x86. But one day we'll come back and show you. But anyway, so what's happening now is the nice thing here is around, we talk about continuity when it comes to IT things and business operations and technology. But you know what a really important one is? End user experience. Try doing change management across a government municipality of 3,000 workers. That is not a fun experience of, where'd my data go? How do I connect to that share? Or, no, it's in the cloud now. I have to log into a VDI. That sometimes is more of a barrier than the technology. It's just getting people to change behavior. So the nice thing is no behavior change. They go home, they plug this in, and they connect to it just like they do in the office. This is effectively the cluster in the data center shrunk down into a little Nook. And now maybe they've flown to another part of the state, maybe they're in a more safe location, they're not affected by the hurricane, and they can still get entirely to their data and still run those mission critical things they were doing relative to, helping figure out what the recovery plan should be or orchestrating with other agencies.
So you could actually mount that cloud folder here if you wished.
And we are just like perfectly aligned.
Is that what we're talking about?
Yes, that's what we're doing. So you know what? You should just come up right now.
No, I don't want to do that.
If you could do the honors, what would it look like to then establish a data portal from this little device that showed only the local data, nothing in the cloud? We do the exact same thing over again. We go create a data portal now. We request the data portal. We approve that data portal in the cloud. That's key, by the way, because I can later revoke it if I want for security purposes to other agencies, et cetera. And that'll go connect to it. And again, the fun part is we have customers with clusters with over 80 billion files in a single namespace. And yet this still works. It blows my mind where you can show that as if it's all local and it's 80 billion files sitting on the cloud. And now here on the little Nook, I have the same data in the cloud that I had before. And so I have the local home data, now I have the cloud data. We saw the old project and new project just like before. I can browse into the new project. And there's Mr. Qumulo once again.
You need to start using better pictures.
Yes. And so again, now I can open this and I love how Paint likes to jumbo size there, but it's the same photo again. Now I'm at home.
Point out the bald
Now
spot
I'm running right off of this. We were running on a cluster in Seattle before, connected to US West 2. Now this is on the Nook, connected to US West 2. The data is in that lifeboat the whole time, right? I don't have to worry about failing over, doing the last iterative replication. When should I do it? None of that. It doesn't matter. I've engineered that continuity into the system from the very beginning. So
I have a question. I assume you were joking about running it on your phone, but is ARM actually on the roadmap?
I cannot confirm or deny, but that sounds fantastic. I did say the word yet, so I kind of gave away the punchline a little bit, but yeah. Yes, the answer is yes. Look, what I love about some of our customers is represented in these little grumquats. I think you already threw one at Doug will once again throw things at me. So the grumquat is because our customers are never satisfied with any innovation we ever give them as their mascot, okay? They're never happy because they always want more. And they get this behavior because we keep delivering on that, okay? Like in the customer experience or other things. And so, yes, we had customers that say, hey, you're 80% less expensive than any other file system in the cloud. That's awesome. But I see these Graviton systems over here that are even cheaper. Could I use those? And what about those same versions in Azure and OCI and GCP? Okay. And then we had some customers in the military side of things and otherwise saying, hey, I have this black box system in a tank or an airplane, and it's ARM-based because I don't have the power to run normal x86. Can I run it there and stream that in real time back to a cloud for analysis on the engine and what's happening? Yeah, okay, that sounds pretty cool. We should probably do that. So yeah, some very interesting things coming in that regard as well. So now we've edited that photo once again, back there on this Nook. We're gonna go ahead and show now, okay, storm's over. We're moving everyone back to the office. They can come back and, in this circumstance at least, let's hope that the whole cluster is still there. But again, the nice thing is that even in the worst case scenario, I can still provide full access to the data the whole time. And, if I have to stand up a new cluster, that's fine. I don't have to replicate any data back to it. I don't have to worry that I lost any data. It's just a cache. It's just an extension of the data that's in that lifeboat in the cloud. And so therefore, don't have to worry about that either. So all we did now is just show how we revoke access to that data portal on the Nook. Again, not something necessarily you have to do, but it's nice for the sake of just having clean visuals of what's happening between the two. And then we'll show that the flip back, here we are in the office. We've established the new data portal. And once again, back, and we can see that, open the new project. This is a cluster in Seattle connected to US West 2 and AWS. And once again, it overzooms, but there's the edits once again.
So if you kept the on-prem one up, and you went in right now and typed something, and then flipped over to the on-prem one and opened the file again, it would instantly be consistent.
Yep.
I did keep them up.
Yeah, they're both actually running. We can show right now if you want. Yeah. Since we have almost 8 minutes, we can show yet more onto the demo. So, made on-prem. There you go. As he's showing this go through, any other questions of how that gets put back together?
So, you asked for a customer story.
Come on to video.
We had a Formula One team that said our car comes into the pits and it offloads the data quickly to a 4-node durable write cache in the pits, which a ton of data gets offloaded to these cars every time they go past. The cloud provider pulls from that data, determines how to reprogram the car, and then transmits that to the car over 5G, reprogramming the car as it's making laps.
Wow.
It's kind of interesting. Or imagine
Well, to be fair, we only helped that customer because you wanted tickets to Monaco GP, but which just recently came back from. But
and Montreal next weekend as well.
No, it's nice when you have really fun customers doing really cool workloads and you get some perks like that.
Every now and then.
Yeah.
But yeah, or imagine one, like we said, where you have 1,500 drones writing data into 2 cloud providers that are different cloud providers, all using NFS and SMB. And imagine that's in an area that might be a target. And so you put it in 2 different cloud providers so you can tell for certain if it's a denial of service attack against the data. That's the spoke. Where would you put the hub? Maybe Tokyo. Where would you put the other spokes? Intelligence community sites. 17 different agencies processing data in parallel. Each one determining different factors. Different face recognition, different equipment recognition. Some doing Blue Force Tracker, some doing different weather overlays. And maybe only at the very top, you can see all 17 different metadata streams and pull them together. But each agency having their own view into the data. Or imagine you want to deploy something forward and you can boot VDI instances off of a read-only portal in the cloud and then write the data back into a write-only one. Stream it back. And on and on. Or follow the sun editorial. Take that, imagine that's not just a 5 megabyte photo taken on an iPhone, but it's a 5 petabyte movie. And now you have editors around the world all working on their different parts of the film, saving it back. Everybody having access to all the work everyone else has done, but instantly revocable if you have a data security issue. When the whole film's ready, you don't have to build a render farm. You move the parts needed up to 3 different cloud providers and render in parallel. You keep all that pre-rendering data in case you need to rerun any frame. And then save it all back to the same central spot, frame by frame by frame, reassemble the whole movie, and ship it out.
You know, it reminds me of many, many years back. I was with a vendor who obviously didn't have the most cloud forward strategy before my time at AWS, which was like upside down world comparatively. And the term data gravity was created by the marketing group. And the idea was to basically say, no, you can't, you have to keep the data here in the storage systems we sell you on-prem. And then also because it's here, you have to keep the compute here. And okay, maybe you can do those like secondary, tertiary things in the cloud and maybe separate workloads. Maybe the shadow IT stuff can go there, but you can't, it's just too much data. You can't move this, right? And what we're finding is that, like, again, if you change how the data flows, if you change how you architect it to be able to account for this, and if you build a file system from the very beginning, Qumulo is Cumulus Cloud, right? That's software differentiated to be able to have the same fantastic experience no matter where it is, what cloud, what region, what hardware, then you can start doing some really interesting things that change how customers perceive the art of the possible and how they orchestrate their data flows. And again, networking is exponentially growing. And if you're extremely more efficient in using it in the first place, plus it's getting faster, you can really start thinking now more, it's not about how do I bring things to my data, it's how do I make my data seamlessly available to any compute, any remote team, any talent you need it, no matter where it is. We have, especially post-writer strike, post-COVID, et cetera, we have media customers. It's actually hard to find one now who isn't using follow the sun production or distributed teams that don't have some teams in different regions or different talent pools because the demand for content is just so high.
You support any public cloud, any of the big public clouds in this situation. Can you stitch together a global namespace across multiple public clouds?
Absolutely. One of our biggest broadcaster that has us on it, working with us today, started with us on-prem, then deployed on AWS for audio, editorial, et cetera, out of New York. And then had a whole other group within the company who on their own, independent of talking to that first group actually, deployed on our Azure native Qumulo system, which is an integrated service with Microsoft that was co-developed as a first-party service. And then figured out, oh, by the way, you all are using us in all, like, on-prem and in 2 clouds. I can just data portal this together so you can collaborate, even though you have your preferences. You prefer those suite of tools in Azure, you prefer those in AWS, you still have infrastructure that's good to use on-prem, no problem. And actually, the nice thing also is we've used this not only for across multiple clouds at the same time, but actually as a migration tool. Yeah. Because the hard part about migrating is like, how do I have to go copy everything first? How do I maintain continuity along the way? When's the cutover? When's the last fail? No. I create new system in Azure, you're in AWS, or vice versa, or OCI. I can make it read-write on both sides simultaneously, and you can move one app at a time, and everything's still running on both sides as I move them across the bridge until you get there. And it helps with M&A, it helps with collaboration. Yeah, so it really helps stitch all that together.
Any good questions, though? Anybody have anything? I mean, you were talking about infrastructure as code, which I think is, to me, a fascinating topic, and the ability to use Ansible playbooks, with Terraform to not only deploy, but then instantaneously provision all the networking functions across the stack. The fact that in the on-premises environment, we can run on the customer's, IA certified version of RHEL 10 that they want with all the plugins they want. See, and
Yeah, 2 seconds.
there's a question. It better be a good question. But running on the customer's IA assured version with all the plugins they want. They want the Cilium driver so they can participate with, have their isovalent integration. No problem. Or do they want to use, a different tool for security vulnerability scanning and have that integrated? Or do they want to have another particular microservices protection tool or distributed host firewall? No problem. Yes.
I can ask something. Do any of your customers currently do any kind of CI/CD automated pipelines? I'm thinking because I'm always forever in GitLab running runners on there.
Yeah.
So what are you able to share kind of some scenarios?
I can give you a simple one to start off with.
Yeah.
In a multi-tenant environment, as you want to add a new customer as a managed service provider, that could automatically, through our APIs, create a new folder. That folder could be mapped to specific rights. That folder could be mapped to a specific Active Directory instance that was used as part of that MSP. Or if they then wanted to extend that to the cloud, that would make a call to our Terraform provider, which would then execute and instantiate that cloud. And then with the work Mike was showing on the CLI, that is all in the API now. And while we're building a UI on top of those APIs, being an API first architecture means I bet if I wanted to spend a rainy weekend in Seattle, I could probably hack up the Ansible playbook to auto create the portals on both sides of that, so that then that customer could have an on-demand DR environment and again, build that lifeboat before the ship took off.
Exactly.
That would just be, do I want to one-click add the service to add DR in the cloud? Yes. And as a managed service provider, the Ansible playbook runs, Terraform executes, it's declaratively provisioning the cloud, it's running until it gets it right, and then add the portal, that provisions to the API call, you get a positive assurance that it's created, and then we deploy some data to it. Then if I was extending that playbook a little more, I'd probably write a series of PyTest coverage guided tests based on the files to evaluate the files were reachable by the protocol set that I had instantiated. So I'd validate SMB, NFS, S3, maybe even FTP. Make sure it's reachable by the protocols I've enabled for that client, and then I'd write that back out as a set of documentation artifacts, publish that to the GitLab or GitHub instance for that client, so they'd have a self-documenting of the results of that runbook I executed. And that would go right into, what me as an MSP was running for my client. And to make it even more fun, you could probably do service instantiation through ServiceNow and ticketing through that and tie it into the complete system where the Salesforce order is executed, the ServiceNow playbook runs, maybe all integrated through iTential, which would then make the Terraform and Ansible runbook calls by the time I was done building the system out.